Hi, today I'm gonna do a teardown of this Lenovo 5-volt 1 amp USB charger. I'm doing a teardown of it because I want to know the quality inside the charger and it loses connection on the USB. So first let's read some markings. Input is 100 to 240 volts, which is universal mains, and 150 milliamps. Isn't that way too high? Okay, let's do some calculations because that's very high. Okay, so let's calculate the input. So 100 volts times 0.15 amps equals 15 volt amps. Okay, we will remember that. I. And output is 5 volt 1 amp. So no, that's the output. Output is 5 volt 1 amp, which is 5 watts, because 5 volts times 1 amp is 5 watts. So let's say it is like 80% efficient. So 1.2 times 5 watts equals 6 watts on the output, because it is probably about 80% efficient. So now the power factor is output divided by input. So 6 watts divided by 15 volt amps equals 0.4. That's quite a bad power factor because this is quite a small load on the grid. Imagine your heater at 2 kilowatts with this power factor. It will draw like 4500 volt amps from the grid, which is a lot. Your heater is purely resistive load, so it is gonna have a power factor of 1. But this has a power factor of 0.4, which is still horrible. Imagine putting this like 10,000 or 100,000 these charges into the grid. It is gonna waste a lot of power. So yeah, that's for that. And let's see some other markings. So other markings are V, that's actually a 5, so it's a 5th class. But oh yeah, I won't try to fix I could fix it, but I won't fix it because it's a bit worse efficiency than what I have. For instance, I have this Huawei Quick Charge, which is 6th class charger, which is awesome efficiency. I also have this Alcatel charger, which is also 6th class. It's lower though, but yeah, this is class 5. This home symbol means it is indoor use only, and this square inside the square means it is double insulated, which means it does not need a ground connection. And these other symbols are actually where it can be used. For instance, I think this GS it means it can be used in Germany. And that's all from the outside. So now I'm gonna try to, yeah, I have tried so like 5 months ago to open it up, but it didn't make it. So let's try now. So I'm gonna give you one tip on how to open this any charger easily. Like put some acetone or a nail polish remover or some fuel. I don't know how is it called, benzene, and it can easily be opened. You just put it outside and it'll open up easily. Okay. Can you please focus? Okay. So it looks fine. It looks a lot better than other dodgy piece of shit chargers. So mains goes in through these two pins, and this is where it touches. So first it goes to the fusible resistor. It goes to the fusible resistor. From the fusible resistor, it goes to the common mode choke, which is actually very rare in chargers. Most of them just go straight up in the bridge rectifier, but this one has a common mode choke, so that's very nice. After common mode choke, it goes to the bridge rectifier. After bridge rectifier, it goes to these two smoothing capacitors. First into this capacitor, and after this inductor, it goes to this second capacitor. And after that, it goes to some switch mode power supply chip. And there's some transistor. And this is the transformer. It looks very safe, and these windings outside the core are probably for interference. Yeah, and it's probably connected to the neutral or something like that. And isolation cannot be seen, but I see it's awesome. Like, it even has this plastic sheet for even better protection. So it looks like a safe charger. And on the output, this is a rectifying diode. This is a Zener diode. This is what? There is actually two capacitors on the output. This is the first capacitor, and after this capacitor, it goes to the second one, which is awesome. Like, this electrolytic one is first, which gets the most ripple, and then this one is for even better smoothing. So this is the secondary, so it does not go under directly under the transformer, but it is it's recessed. So a very nice power supply, I must say. And there is a inverse resistor, which is and a diode, which is also a fuse and an inverse resistor all in one. So if I was going to do some upgrades, it would be this diode, better quality capacitors, and that's all. Because it looks like a very good power supply. I won't be putting it back together, and you can see what acetone did to the plastic. So I'm 100% not gonna be using it again in this package. I'm sorry that I'm not gonna do a scheme of this, but it's one transistor, but it's a IC and a transistor. Good thing it is not a classic 2 transistor power supply, but it has a chip. It does not have optocouplers because the transformer is very well designed, and it can read the voltage only from the from some sensing winding, which is awesome. So thank you for watching, and I will see you in next video.